There are many Superfund sites, which are polluted locations that will require long-term actions to clean up hazardous material. Here we will be examining lead pollution in Torreon, Mexico, and in particular, the Metmex Peñoles metal factory. The purpose of this presentation is to bring awareness of how metal refineries in Torreon, Mexico are responsible for contributing to environmental lead pollution and for harming children's health. We will first discuss how the metal refinery process, specifically that of silver and lead production, produces environmental lead contamination. In particular, we will be looking at data from Metmex Peñoles, which is one of the largest metallurgical industrial sites in the world and the largest producer of silver. We will then examine how environmental exposures to lead may contaminate homes and schools and eventually harm children's physiological and developmental health. Lastly, we will review possible considerations for reforms that improve environmental health. Lead is an important element that is widely used in industries for its ductility and corrosion resistance. It can be found in batteries, pigments, and even in equipment for radiation protection. When lead ore is mined, it must undergo sintering, smeltering, and refining processes to be made into usable material. These processes help isolate pure lead from other metals found in the ore sample, and during each of these processes, lead dust and smoke is released into the surrounding environment. In Torreon, Mexico, there are many metallurgical sites, with the largest being Metmex Peñoles, which is situated at the heart of the city. This large metal producer creates more lead pollution than all of the other sites in this area combined. Silver is a small component of lead ore, and in order to extract silver from it, lead particles are released. Here we can see that over time, silver production has increased steadily at Metmex Peñoles, which suggests that more lead dust and particles are also being released into the surrounding areas. Not only does lead ore contain silver, but it also contains copper and zinc in addition to lead. Here we can see that generally over time, the amount of lead, copper, zinc, and silver produced in millions of tons has increased at this site. As a result, metal production may be the main contributor to lead exposure in Torreon. Near these metal industrial sites, we can see dense clusters of residential and school sites. Studies have shown that children who live closer to Metmex Peñoles were more likely to have higher elevations of blood lead levels than children who live farther away. The highest blood lead levels in children were among those who lived within half a kilometer to this location, with blood lead levels ranging from 20.3 to 32.5 micrograms per 100 milliliters. Children who lived 4.5 kilometers away also experienced elevated lead concentrations in their blood, with levels ranging between 3.3 to 9.5 micrograms per 100 milliliters. These are still levels considered unhealthy by the CDC. Overall, polluted sites can be found around active smelters, foundries, and factories. Additionally, children who lived in the direction of prevailing wind patterns also experienced higher blood lead level concentrations compared to children who did not, since wind and rain can spread contaminants. Studies have shown that 92% of children who live 0.5 kilometers southwest of Metmex Peñoles had elevated blood lead concentrations that had the potential to cause severe organ damage and cognitive developmental impairments. Due to close proximity to active factories, lead concentrations in the surrounding areas near Metmex Peñoles are highest in soil and dust. Dust and soil in playgrounds and residential areas are the most likely routes for lead exposure in children, whereas lead exposure from drinking water was rare and uncommon. Cross-sectional studies have shown that about 77% of children living close to the Torreon smelter would require treatment for lead poisoning, and about 66% of these children had elevated blood lead levels that could cause severe organ and nervous system damage, as well as delayed growth. There have also been some cases of children requiring hospitalization due to lead poisoning. Therefore, programs will be necessary to regulate and reduce the amount of lead pollution that is released into the air and ground soil by metal factories in order to improve children's health outcomes by minimizing the incidence of toxic lead exposures. In summary, metal processing can produce toxic lead byproducts that can contaminate soil and air of surrounding neighborhoods. Lead exposure can negatively impact children's physiological and neurological development, and there should be reforms to regulate the amount of lead pollution released by metal factories.